Welcome, class, to the Intro to Java Programming. This is the third of 6 lessons on operators. Today, we will review relational operators along with code examples. We will also spend a little time with equality. Operators are used to perform operations on variables and values. Those operations can be in the form of expressions or conditions. Expressions can produce a value, assign a value, and possibly do nothing, like in the case of a void method call. A condition is used in a decision process to determine if the evaluation of two expressions are true or false. One example could be, is 3 greater than 2? This is a true condition. In this lesson, we will focus on creating conditions with the use of relational operators. Let's go over the 6 relational operators. There are less than, greater than, less than or equal to, greater than or equal to. 2 equal signs are used for the equal to or equality. Remember, one equal sign is used for assigning a value to a variable. And exclamation mark with an equal sign is used for not equal. Remember, exclamation mark represents the word not. Relational operators are very easy. You should have covered this topic in math class when you were about 8 or 9 years old. The only small exception are the symbols used for equal and not equal to. Good question. Relational operators are used to create a condition, and conditions are needed for the decision process. Let's talk more about a condition. Remember, a condition is used in a decision process. It will determine if the evaluation of two expressions are true or false. Check out this visual. Imagine this big diamond is a condition. There is a relational operator, let's say it's greater than. There will be an expression on the left. Remember, an expression can be a value like a number. It could be a variable like gross pay. It could be an expression like hours worked times pay rate. And it could even be a value returned from a method like get gross pay. For this example, let's use a variable called strike count. On the right, there will be another expression. Let's use the number 2. Remember, everything you see inside the diamond is used to evaluate a condition. There will be an expression on the left, a relational operator, and an expression on the right. The idea of evaluating a condition is to determine if the result is true or false. For example, there are many rules in baseball. One rule after each pitch, if the batter has 3 strikes, he is out. The condition we built will determine if the batter has struck out. So, if the batter has 2 strikes, what is the result of this condition? Correct. The evaluation of this condition is false. A decision process after the pitch will determine the batter has not struck out and can continue to bat. If the batter has 3 strikes, what is the result of this condition? Correct. The evaluation of this condition is true. The decision process after the pitch will determine the batter has struck out and his turn at the plate is over. Later in lesson 21 and 22, we will go into more details on the decision process. First, it is important to know how to create a condition, something that will be true or false. Let's go to our basics project in IntelliJ, close any open class tabs. Let's navigate to the operators test package. Let's create a new class called Relational Test. Let's make some space. Copy in this first test. Import in these classes. This first test will show a condition using the less than sign. Here we create 2 primitive variables. Here is a condition that evaluates the 2 expressions. Remember, this will be an expression, and this will be an expression. The result of this condition should be true. Here's a condition that has a more complicated expression. This expression needs to be calculated. Just to show a false condition, we will test to see if 100 is less than 73. If we run this test, it passes. Here's a similar test that shows less than or equal to. We create and set 2 primitive variables, and we test to prove that one condition is true and the other is false. Let's run this test. And it passes. Here are 2 more tests that show greater than and greater than or equal to. In each test, we prove one condition is true and another is false. Let's run each test. This one passes. This one passes. This test will prove that two primitive variables are equal with the double equal sign. We create and set two primitive variables, and here we prove one condition is true and another condition is false. Let's run this test. And it passes. Here's the opposite test to prove two primitive variables are not equal with the exclamation mark and equal sign. We create and set two primitive variables, and here we prove one condition is true and another condition is false. Let's run this test. And it passes. Do non-primitive objects work the same? The short answer is no, specifically with equal to and not equal to. The way values of a primitive are held in memory differs from the way non-primitive or object values are held in memory. The primitive value is stored in the stack, a special location of memory. To make it simple, Java knows the name of the variable and the value it holds. The non-primitive object is also stored in memory, but in a different location, not the stack. Java also knows the name of the variable and a reference location to where the object is held in memory. Because of this subtle difference, when testing equality, you need to be aware of the variable. Is it a primitive or is it a non-primitive? When testing for primitives, use the double equal sign for equality like we did in the previous tests. When testing non-primitives, the double equal sign can give unexpected results. Let me show you a few examples. This test will check the equality of two string variables. Here we declare and set two string variables. The assert will use the double equal sign to see if these variables are equal. If we run this test, it passes. Time for a Coach Joe challenge question. In this test, what was tested for equality? Correct. Both strings have the same reference. The value Coach Joe was not tested. Where the variable references are pointing to was tested. Let's prove this with an addition to the test. Let's add a new variable that holds Coach with a space at the end, and another variable that holds the word Joe. And let's create a third variable that concatenates the two new variables together. Now with this assert, we will test if string value 1 equals string value 3 with the double equal sign. Do you think this test will pass? Let's run this test. And it fails. The values might be the same, but the double equal is testing the reference. These two values are stored in different locations, therefore the test fails. To test the value of a non-primitive object, we use the dot equals method. Here's the same test. Instead of the double equals, there is a dot equals method. The value of the first string is testing the value of the second string. Let's run this test. And it passes. Sure, here's a test to help show the object reference. On this line, we create a payRequest object. On this line, we create a new payRequest object. If you look closely, they have the same property values passed into the constructor. Since there are only two properties in this object and we set both properties the same, you might think these objects are equal. Back in the test, we will output the value of each object. And since I know these objects are not the same, I will test for assert false. Let's run this test. And it passes. Notice the output below. There are two different reference values. This proves each object is pointing to a different location in memory. It also proves we are testing the reference with the double equals, not the value. Now let's prove these payRequest objects are equal with the dot equals method. Inside the payRequest class, let's add these two methods. Back in the test, let's add an assert to prove these non-primitive objects are equal. If we run this test, it will pass. Now we've proven the objects are equal. Look for a Coach Joe workshop on equals and hash code in a data structure to help with testing for equality in objects. You may want to do some additional research to learn more. Here's a summary of the code that we wrote in this lesson. You should now have a better understanding of the 6 relational operators: less than, greater than, less than or equal to, greater than or equal to, along with equal to and not equal to. You also learned that when testing for equality, a primitive will use the double equals and a non-primitive will use the dot equals method. In the next lesson, we will discuss logical operators. Remember, future senior developers, make it work, prove it works, then make it better. Ready?
Break!